Merry Christmas, Honors Algebra. Mr. Lawrence here with your winter break video number 3. This one will be focusing on Chapter 6. On Chapter 6, if you can recall, covered such important topics as solving compound inequalities, absolute value graphing, absolute value equations, or functions as the case may be. And that's basically the gist of it. This video should be much shorter than the last one because Chapter 6 is not as long. All right, so let's see. Let's get right to it. Let's get into solving inequalities. And we'll talk about the compound ones, but we'll start with just a multi-step inequality. Say we have something like this. 5 minus 3x over 2 is less than, I don't know, 6. Okay, to solve this one, if you want to pause the video and try to solve it on your own, that would be awesome. If you're listening to the video now, I'm assuming you want to see my solution. My first step is going to be to multiply by 2 on both sides. 2's will cancel, and I will have 5 minus 3x, which is less than 12. Okay, now I have a two-step inequality, so I will subtract 5 from each side, leaving me with negative 3x, which is less than 7. And then I need to divide by negative 3. Whoop, 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 whoop. All right, x will be greater than negative 7/3, or since I'm going to graph it on a number line, I might think of it as negative 2 1/3. Draw my number line. I put a negative 2 1/3 down. It's an open circle because, or an open point, because it does not say equals. And then I want the numbers where x is greater than negative 2 1/3. If you're a kid that has trouble with that, please rewrite it like this, and then fill in the blank with something that makes it true. Oh, 5 would make that true. So I'll shade towards where 5 would be on the number line. And it's just that simple. All right, when we have a compound inequality, there's two types. Some of them look like this. Okay, and some of them look like this. 3x is less than 12, or x minus 7 is greater than 20. Okay, I'll solve them each individually. Of course, you can feel free to pause the video at any time, try to solve them on your own, and then unpause them when you want to see my solutions. All right, so I'll do the left-hand side first. Some of you like to rewrite this into two problems. You like to rewrite it as this, and then you go 3 minus 2x is less than 7. That is a legitimate way to do it. To me, it takes longer. I don't want to do extra work, but if it helps you get it right, then please go ahead and do it that way. All right, for the purpose of the video, I'm going to do it as one long inequality. So I see I want to get this 3 away from the 2x, so I'll subtract 3 in all 3 places. When I do that, I end up with negative 9 is less than or equal to negative 2x, which is less than 4. Make sure you don't lose that negative right there. Okay, now I got to get rid of the negative 2. It's attached by multiplication, so I'll divide by negative 2. Whoop, 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 whoop. Whoop, 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 whoop. You got to remember to flip that inequality. This will come out to be 4.5 greater than or equal to x, which would be greater than negative 2. I go to draw it on the number line. I have to show negative 2. I have to show 4.5. The negative 2 will be an open point. The 4.5 will be a closed point. And there we go. All right, this one over here, it will be in two parts, or as you cannot do as one sentence, you must do them in two parts. So I'll divide by 3 first of all, and I'll get x is less than 4. Or here I will add 7 to both sides, and I will get x is greater than 27. On my number line, I'll show 4, I'll show 27. They will both be open points. And then I will say x is less than 4. Well, the numbers less than 4 are this way, to the left of 4. X is greater than 27. The numbers greater than 27 are to the right of 27. And there you go. Okay. One thing I do want to point out, notice on this one here, I didn't do two parts to it, did I? I just did it as a simple inequality. Just solved it straightforward. There are not two parts to it. Why aren't there two parts? Well, on these, there were two parts because I was given two parts to begin with. But one thing some of you were confusing on the most recent test we took was when we had something like this, this is a problem that has two parts to it. You have to consider both sides of the 0 point, okay? So you have to say, well, x could equal 5, or x could equal -5. But if there's no absolute value in the problem, like on this one here, there is no absolute value symbol, right? No absolute value symbol, right? No bars like that. Then you don't add another part to it, okay? These two are written in two parts. See, you've got an inequality here and an inequality here. This one you have this side, and then you have that side. So they're written in two parts. That's why we do them in two parts. This one, because of the absolute value, you have to consider both numbers on the side of a certain center. And sometimes that center is 0, but not always. In a problem like this, it is 0. Because remember, the definition of absolute value is the distance from 0 on a number line. So if I looked at a number line, and I found 0, and I looked at 5 and -5, both of these are 5 spaces away from 0 on a number line. That's why this has two answers. Okay, so let's see here. By the way, what would the absolute value of -3 equal? This would be no solution. No solution. There is no answer to it because, oh no, Mr. Lawrence, I'm confusing myself. Excuse me. Excuse me. The absolute value of -3 would be 3. Silly me. Sorry about that. Because -3 is 3 spaces, 1, 2, 3, away from 0 on a number line. Well, the question I was meaning to ask that I had in my head was this. This is no solution because there are no numbers on a number line that are -3 spaces from 0 because distances are always positive. All right, how do we do a problem that looks like this? Or a problem that looks like this? Okay, these are the problems that have two parts. This is an AND problem. How do I know? Because less than. This is an OR problem because of great or. Great or. This was less than, right? Okay, to do an AND, I like to do them as one sentence. Some of you like to break them up. I like to take 2x plus 1 is less than 6, and then take this inequality and change the sign. I'm actually flipping the inequality. Some of you like to do it in two pieces. That's fine, you go ahead. Now, it's just like the problem above that I did. So, on this one, I'll subtract 1 here, here, and here. When I do that, I will get -7 is less than 2x, which is less than 5. I will need to divide by 2, divide by 2, divide by 2. And then I will get -3.5 is less than x, which is less than 2.5. On a number line, negative 3.5, 2.5, both open, and shade in the middle. Remember, if you hold your fists out in front of you and then point your thumbs towards the middle and touch them, that is how ands end up looking, except for in the rare case when you have no solution. A no solution would look like something like this, where you have the absolute x plus 1, and that has to be less than negative 1 or less than 0, meaning the distance will end up being a negative, because this part refers to the distance from 0. Okay? So this distance has to be less than negative 1. This would be a no solution problem. Okay, if you solve it, you'll end up getting something bizarre like negative 13 is greater than 5, something that doesn't make sense. All right, so let's go back to the other problem, the OR problem. I need to write it in two pieces, greater than 13, or 3x plus 4 is less than or equal to negative 13. And now I'm just going to solve both parts, just like I did on the problem above it. I'm going to show all the work here at once. I strongly recommend that you do one side and then the other. 3x greater than or equal to 9 divided by 3. So x is greater than or equal to 3. Or this will get me 3x is less than or equal to negative 17 divided by 3. Will get me that x is less than or equal to negative 17 thirds, which would be negative 5 and 2 thirds. On a number line, would look something like this. I colored in the points because they are equal to. Okay, and again, when you hold your fists out in front of you, turn your palms up while your fists are still made, and then stick your thumbs out. Now your thumbs are pointing out to the right and out to the left, not in toward the center. That is what ORs typically look like, unless you get a special case like this, where you get the absolute value of x plus 5 has to be greater than 0. Well, greater than or equal to 0 or greater than or equal to a negative number. That will be true for all real numbers. No matter what I put in for x, I will get at least 0 or a number greater. That'll be an all real numbers solution. Okay, any number for x works. Okay, so let's see here. Where am I? All right. By the way, remember these problems are in that packet that you were given right before break. So please go ahead and feel free to work on them. All right, the last thing we need to work on is graphing absolute value functions, and that'll include finding the domain and range. And these are real simple. Let's say I have an equation that looks something like this. Y equals 2 thirds absolute value of x minus 4 plus 3. The first thing I'm going to do is find the vertex. Find the vertex. Well, my x-coordinate of the vertex is here, but remember, I changed the sign. The y-coordinate of the vertex is here, but I don't change the sign. So my vertex occurs at 4, 3. So let me get some graph paper out here. And let me see, get rid of that. All right, so I know my vertex is at 4, 3, right? So I'm going to count 1, 2, 3, 4, 1, 2, 3. I know that my V is going to open upward. How do I know that? Because my slope is positive. My slope is sitting there. So my V will open upward. So I will rise 2 and then run 1, 2, 3 from the vertex. But because of symmetry, I'm going to rise 2 and go back 1, 2, 3. Okay. 1, 2, 1, 2, 3. And then 1, 2, 1, 2, 3. And there we go. All right. I draw my V in, and it'll look something like this. And there it is. Okay. Now to find the domain, remember, I'm going to test all the possible x values. I like to use a vertical line to help me do that. And I'm going to ask myself, is there any place I can put this vertical line that it will not eventually run into the v? Well, it's certainly going to hit the v when x is 0. It hits it right where that crosshair is. Okay. It hits the v when it's positive, definitely when it's 10. Will it hit it way out here? Like when x is, say, 65? Sure it will, because remember, these graphs go on forever and ever and ever. So sure enough, my vertical line will intersect it eventually. Okay, let's go back this way. Let's see at the negatives. It looks like it's going to hit the negatives, going to hit the negatives, going to hit the negatives. Yep, yep, yep. Will it hit like when x is negative 200? Sure it will, because looks like my thing got moved a little bit. The line goes forever, the ray goes forever, and so therefore it will hit it. So there is no place where my vertical line will not hit the v. So I say the domain will be all real numbers. Okay, the range now. The range, I like to use a vertical line because it tells me my y values. So let me get a vertical line here, and I'll make it magenta or purple or whatever color you want to call that. And I notice that down here, I'm not hitting the v, am I? What's the lowest point I hit the v at? Oh, right there at the vertex. Yeah, the vertex will either be the highest point that you hit the v at or the lowest point that you hit the v at. It's either the highest or lowest point of the v, of the picture. Okay, so this y value is 3. And I notice that all my other y values are going to be more, like the y values for here, 5, 6, 7, 8, and so on. So my range is going to be all y's that are greater than or equal to 3. And there's my range. Okay? Now remember, domain does not have to be all real numbers. It doesn't have to be. It just turned out to be in that case. All right, one more quick example, and then we'll end this video. Let me see how I'm doing on time. Yeah, we're not even going to be 20 minutes. All right, so your equation this time is y is equal to negative 3 times value of x minus 2. Okay. Why don't you go ahead and pause the video and see if you can graph it yourself. If you're still watching, I'm going to assume you want to see a solution from me. So here I go. First, I'm going to find my vertex. I look in here for my x-coordinate. I don't see anything in there. Oh, that means the x-coordinate must be 0. I look out here for my y-coordinate, and I do not change the sign. And there's my vertex. So my vertex occurs at 0, negative 2. 1, 2. There we go. Okay, I look here for my slope. My slope is negative 3, or as a fraction, negative 3 over 1. Remember, the slope is negative, so the v will open downward. So I go down 1, 2, 3, right 1. But because of symmetry, I also have to go back 1. Down from this point, 1, 2, 3, right 1. But I go from the other point, 1, 2, 3, back 1, and there is my v. All right. So, looks something like that to do my domain and my range. In this case, my domain will end up being all real numbers because there is no x that will not be a part of this graph. I can put any number in for x. My range, however, will not be all real numbers because I notice at the vertex, the point 0, negative 2. That's the highest point of this graph. No y value will be higher than negative 2. That means y must be less than or equal to negative 2. And there we go. All right, folks, as promised, this video was considerably shorter. It wasn't even 20 minutes. I hope you're enjoying your break, getting charged up to come on back to work. We got a lot to do before we take that midterm on January 11th. All right, Mr. Lawrence signing off.